Now we have Igor Chernienko with us, the chief leader researcher of TINRO, machine learning for pelagic fishing support in the Northwest Pacific. This is the topic of his presentation.
Итак, Игорь, мы с вами практически.
Igor, we are waiting. Are you online? Good afternoon. My name is Igor Chernienko, leader researcher of All-Russian TINRO Institute. I'd like to present our results, which we achieved with my colleague, Igor Chernienko, chief specialist of the same institute. Our paper is called Machine Learning for Pelagic Fishing Support in the Northwest Pacific. Annually, several dozen of vessels are involved in pelagic fishing. Predominantly, these are mid and big tonnage cost. The pelagic fishing provides a lot of jobs and support big infrastructure like refrigerators and processing facilities in a very important region of Russia. A chub mackerel is an important commercial species widely distributed in Pacific temperature, and operating forecasting, which is identification of prospective catch area, provides to increase the performance. The methods of operative forecasting on the environment are used for 50 years already, and use of machine learning is one of the most obvious ways which needs to be used in fisheries. Starting from 1980s, the Scombri was in depression, it was in 2016 again. Since that time, the part of the vessels works in the exclusive economic zone of Japan on the exchange quotas. For our use, we use the data for Kuril and Japan region, and the forecast we do for South Kuril. Scombri comes in autumn, when the peak fishery season is in October. The used data were used as markers for fishery arrays. As predictors, we used the temperature measured at the surface available from all sources, from NOVA site and from the Japanese Meteorological Agency site. We used the ARSAs with special packages. The model learning was done in LightGBM library with the gradient listing model. It is very well known, due to the good temperature regime, the localization of massives are impacted by special gradients. We also calculated difference of temperature, which reflected local trends in the environment. The marking was done by delineating by nuclear density. The kernel density was used. The density over 50% was marked as 1, all others as 0. As a result, the forecasting task was reduced to binary classification task. Preliminary learning indicated that we have lags from 4 to 7 days, which is biologically grounded. The organisms should be allocated and it needs time. On this slide, we show the chub mackerel fishing ground identification for 3 days, and this is the maximum opportunity to see the vessel in this location. Afterwards, we validated the model, and we see the justification for typical situations which appeared during the fisher period. A, 1 catch, B, first a significant catch, C is the average catch area, and D is the maximum catch volume. As we can see in the forecasted polygons, not less than 70% is caught of the whole volume per day. For the whole period of observation in the Russian areas, we took around 70%. Intensive period embraces 84%. In going forward, we'd like to develop our work and use neural networks. For now, we started to improve forecast on the good fishing conditions. We split it in several classes due to the daily catch of the vessel. We use neural network using the Torch library. On this slide, we show the preliminary results for ANN multi-plus fishing area identification. The range is correlated with the daily output. For now, we verify it for the campaign of 2018. The binary classification allowed to forecast accumulation and provide to make forecast within a lead time of up to 3 days. Over 84% of total catch for intensive fishing period was within predicted fishing grounds. The deep learning will detailize fishing area forecast, and the forecast can be specified. This work demonstrates good perspective of using deep learning and machine learning to forecast fishing conditions in the fishery and in our institute in particular. Thank you for your attention.